Hi, welcome to Misty's Math, your 0606 Math Specialist. Now this video doesn't cost you anything, but perhaps for a support, you can click the subscribe button.
Today we are going to discuss Cambridge IGCSE Additional Mathematics 0606. Now this is paper 1-1, which was answered during October-November 2024 examination. Alright, let's start. So question 1, you have a graph. It says here the diagram shows a graph of y equals to modulus of fx, where fx is a cubic polynomial. Cubic means it is to the power of 3. The degree is 3. Right, that's cubic. So you're expecting that the highest power is x cubed. Find the two possible expressions for fx in terms of linear factors with integer coefficients. So when they want it in linear factors, you are expecting to have those factors, all right, written in linear form, which means it must be the degree of 1. Linear is degree of 1. So let's see the possibilities. You can see that the roots of this cubic polynomial is at -4, 0.5, and 2. Means that you are expecting this to be x plus 4 as one of the factor, and then you also have this is going to be x minus 0.5 or half, or this can be written as 2x minus 1. So we don't have any changes on the first one. It is x plus 4. The second one can be written as 2x minus 1. And the third one with the root at 2. So this would be x minus 2. And there is no changes on that one. Now you just need to think, because the y-intercept is at 24, you are expecting to have the number without any x, which is a constant, as to at 24. If you think about expanding this cubic polynomial, you will be having 4 being multiplied with -1, being multiplied with -2, because that is where your constants without any x would come from. So 4 times -1 times -2 would give you 8, right? Would give you 8. Now that is not 24. You have to think that there must be a number being multiplied in the front that would give you 24, and that number must be 3. Okay, the number must be 3. 3 times 8 equals to 24. Now since this is modulus, we have a possibility that your graph actually shapes like this. All right, from the down it goes up, okay, all through the way, and then it goes like that, okay, towards the end. Or your graph could be, instead of that, it could be this. From the top, it reflects down here, and then it flips up here, and it goes there. Right, there are two possibilities. So because of the modulus, you are expecting to have a positive or negative 3, x plus 4 to x minus 1 times x minus 2. Right, so that is your final answer. Easy? Yes, that's for 3 marks. And how do you get marks for this? The first mark you're going to get when you consider, I'm sorry, I forgot the equal sign there. When you consider the positive and negative sign over here, that's your B1, first mark. Second mark is when you have 3 in the front here. When you think that it must be multiplied with 3, because without the 3, you won't be having the y-intercept at 24, right? When you got the 3, then you'll get the second mark, B1. Now, the last B1 is when you have all 3 terms, x plus 4 to x minus 1 and x minus 2. Okay, that is your last B1 mark. And altogether, you can have 3 marks there. Next, question number 2. Given that 256 to the power of x plus y times 16 to the power of -2x is equal to 8 to the power of -x plus 3y, show that y equals to 3x. Right, you can see that your y, instead of it is being at the index, it became a base. So you have to think of a way on how you could, instead of remaining your y in the place of the index, it would be a base. Okay, let's look at the numbers given to you. So you have here 2, 5, 6, 16, and 8. In a way, you should be able to think that you can write everything into the base of 2, which 256 is just 2 to the power of 8. Yes, and then you still have the index of x plus y. 16 is 2 to the raise of 4 to the power of 4. You still have the index of negative 2x. And 8 is just 2 cubed. Still have negative x. I'll erase it for a while. Negative x plus 3y. Okay. Now, since you have the base to be the same, you can operate the indices. When you have the same base with multiplication, what happens to the indices? You're going to add the indices together, right? So it will be 2 to the power of 8x plus y to be added with 4 times negative 2x, which is equal to 2 to the power of 3 negative x plus 3y. You have the same base now, which means if the base is the same, the indices should also be the same because of the equal sign over here. Those on the left is equal to those on the right. Your base is the same, means your indices should be the same too. Alright, now in that sense, you can equate the indices from left equals to the right side, which is 8x plus 8y minus 8x must equal to negative 3x plus 9y. You can just rewrite this to get to what the question is asking you to show. You have to check to make sure that you are getting to the same point. At this part, you are having 3x is equal to 9y minus 8y. I think I can see that it's going to be y equals to 3x. Proven, right? Oh, shown. It's done. 2 marks. And how do you get marks for this? First is when you are able to write everything into the base of 2. This is the first M1. A1 is when you show sufficient detail that you are getting into y equals to 3x. Okay, that's your A1 mark. Next, question B. Hence, find the exact solutions of the following simultaneous equations, right? Now, first equation here, you can just simplify this into, because you have shown that this is just y equals to 3x. Okay, now this is simultaneous equation. You can do this together by substituting your y with 3x. So you can have there x squared plus 3 times 3x squared is equal to 56. You just need to expand and simplify. This point you should have x squared plus 27x squared is equal to 56. Please make sure that you are expanding the square first before multiplying with 3. Right? Next, this is 28x squared. That is equal to 56. X squared is equal to 56 over 28. Square rooting this, then you should have x is equal to positive and negative of 2. Alright? Now when you consider x is equals to negative 2, what happens to your y? You should be getting that your y, substituting 3x, right? It's basically 3 times negative 2. Should be getting negative 3 2. Right? That's the first combination. When your x is positive square root of 2, then your y would be 3 square root of 2, positive 1. Okay, you should be having these two answers. First combination, the second combination. All right, how do you get marks for this? You'll get the first mark when you substitute y or x into another equation. This is your first M1. The second and the third mark would come from the correct pairs that you have here. You should have two pairs, right? So this is A and this is another A1. Okay, altogether 3 marks. Next question. Question number 3. The diagram shows the graph of fx equals to a cos bx plus c, where a, b, c are constants. Given that fx has a period of 960, find the values of a, b, and c. Right? When it is given to you in the form of fx is equal to a cos bx plus c, you need to know that b is just in 360 being divided by the period, which is 960, right? Which is simplified to be 3 over 8. It means that from 0 to 360, you would be seeing only 3 per 8 of the period. Okay, now how do you find your a? You should see that the maximum is at 6, right? The peak of this function is at 6. Means that you're expecting to have 6 is equal to the stretch, which is A is the stretch, plus the C is the translation, right? In order for you to equate into an equation, you should see that this point is happening when your x is 320, then your y would be 0, right? So basically, when x is 320, your fx would be 0. Now that is what I'm going to use. So I have here f 320 would be a cos b is 3 over 8 times 320, which is my x, plus with c, and this would give me a 0. Therefore, cos 3 per 8 times 320, that's just negative half. I have negative a over 2 plus c is equal to 0. Okay, then I can rewrite this. C is basically a over 2. Right, c is equal to a over 2. I'm going to put it back into my second equation here. That is 6 is a plus c is a over 2. Then I can have, I'll multiply everything by 2. That is 12 equals to 2a plus a. That is 3a. 3a is equals to 12. Then a is equal to 4. Once I get a is equals to 4, then my c would be 4 over 2, which is 2. Right? So I got that my a is 4, my b is 3 over 8, and my c is 2. Let's see, how do I get my points over here? I got my first point when I find b is 3 over 8, that is b1. My second mark is when I equate that 6 is equal to a plus c. That's a method mark 1. Third mark is when I found that c is 2 and a is 4. This is a1 and this is another a1. Right, altogether 4 marks. Moving on to my next question, question number 4. It's given that integration of 8 over 4x plus 3 from 0 up until 2a plus 1 with respect to x is equal to ln 16. Find the exact value of the constant a. Now, how do we do this? You need to work out on the integration from 0 up until 2a plus 1 of 8 over 4x plus 3 dx. Now, this is what I'm going to do. When I have x to the power of 1 written on denominator, integration of this with respect to x would give me ln x. Okay, that's something that you need to remember. When I have integration of 1 over 2x with respect to x, then I would be having ln 2x divided by the derivative of 2x, which is 2. Okay, now what if I have integration of 3 over 2x with respect to x? Then I'll be having 3 ln 2x. And then remember, I'll be dividing with the derivative of whatever in my ln, which is 2. Or it can be written as 3 per 2 ln 2x. Okay, so in this situation, if I'm going to integrate, I'll be having 8 would remain there. And then I have ln 4x plus 3. And then remember, what do I have to divide with? I have to divide with the derivative of 4x plus 3, which is 4. Okay, we clear that? And then my limits would be from 0 up until 2a plus 1. What do I do with the limits? I'm going to substitute it in the place of x. So 8 over 4 is just 2 ln 4 times 2a plus 1 plus 3 to be subtracted with 2 ln 4 times 0 plus 3. So now it's just going to be expansion and substitution. 2 ln 4 2a plus 1 plus 3. That would give me 2 ln 8a plus 7. Yes? 4 times 1, which is 4, plus 3. That is 7. Okay? Which will be subtracted with 2 ln 3. Okay? 4 times 0 is 0, plus 3 is 3. And this everything is equal to ln 16 is given in the question. Alright? You have to figure out what is a. So, you want just this part over here, isn't it? Your a. You can move out your negative 2 ln 3 on the other side. So it will be 2 ln 8a plus 7 is equal to ln 16 plus 2 ln 3. Then what happens? And divided by 2, you won't be having this 2 anymore. As you have 2 at the denominator, this is basically the same as you writing it half over 2, right? You can see that this one will be gone. Now half ln 16 is just the same as ln 16 to the power of half. 16 to the power of half is 4, which is equal to ln 4 plus ln 3, right? Or 4 times 3. 4 times 3 equals to 12. Okay? So with both sides having a single ln, means that whatever in the bracket must be equal together. What we can do here is just equate 8a plus 7 is equal to 12. Therefore, 8a is equal to 12 minus 7, which is 5. Then a is equal to 5 over 8. Okay, so you got the exact value of constant a. Let's see, how do you get marks on this question? First, you will get mark when you have this as your integration. That is your first B1. Second mark is when you have 2 ln 8a plus 7 minus 2 ln 3. Okay, that is M1. Next mark is when you are able to use the rule of logarithm. Using the rule of logarithm, which is this, M1. And that is also when you are able to equate them together. That's your B1. Okay, correctly. Finally, when you get A equals to 5 over 8, that's your accuracy mark 1. So altogether, 5 marks. Next question, question number 5a. In the expansion of 1 plus kx to the power of 15, where k is a constant, the coefficient of x cubed is negative 29,120. Find the value of k. Now you have to think about where will you be having x cubed. When you are expanding this in an increasing power, then you should see that your power is located in that term, which is kx. Okay, the first term would be 15c0 with kx, power of 0, and then 1 to the power of 15. Okay, that's going to be a first term. Second term would be 15c1 kx to the power of 1, and then 1 to the power of 14. What you need to remember is your power would add up to 15, right? 1 and 14 is also 15. And then from there, think about when are you going to have x cubed. So x cubed is going to be, this is x to the power of 0. This is x to the power of 1. So next will be x to the power of 2. The next one will be x to the power of 3, which is when you have 15c3, right, with your kx, power of 3, with your 1 to the power of what? Remember, the power must add up to 15, means that it must be power of 12. And this would equal to negative 29,120 x cubed. Okay, you can get rid of the x cubed anyway because you just want to find out the value of k. Having this, you just need to calculate what is 15c3 k cubed, right? And equate to negative 29,120. Your k would be negative 4. How do you get marks for this? You'll get the first mark when you equate this, okay, correctly into negative 29,120. That is your method mark 1. The second mark is when you get it correctly, that k is equal to negative 4, A1. Okay, next, question B. Find the term independent of y in the expansion of 8y squared minus 1 over 2y to the power of 12. You should be thinking about, okay, your first term is 8y squared. Your second term is negative 1 over 2y. Okay, as I mentioned earlier, when you expand this, your power, they must be add up to be 12, right? Now think about what are those powers that when you multiply this, you will be cancelled off your y. Your y would be having to the power of 0. That would be cancelled off. Okay, what I can think of is when I have 4 over here and 8 over here. You think the same? Because in this sense, I'll be having 8 to the power of 4, and y would be to the power of 2 times 4, which is 8. And then I'm going to multiply this with negative 1 to the power of 8, that is just 1, over 2 to the power of 8, and then y to the power of 8 also. You see, my y would be cancelled off. Now your task is to think about what would be the constant, what would be the coefficient. Since you have found that this is going to be 4 and 8, you can have this 12c4, okay, and then having 8y squared to the power of 4, and then negative 1 over 2y to the power of 8. Okay, remember that 12c4 or 12c8, they are just the same. And then when you compute this, you should be getting 7,920. How do you get points? You'll get the first mark when you thought about having 8y squared to the power of 4 and 8 with the correct coefficient, which is 12c4 or 12c8. Okay, having this is going to be your first mark, M1. Second mark when you have 7920, that is your A1. Okay, let's move on. Question number 6. The polynomial p is such that px is ax cubed plus 11x squared plus bx plus c, where a, b, c's are integers. It is given that p prime 0 equals to 12. What does it mean by p prime? P prime in this situation is the first derivative when you differentiate it. Okay, the first derivative. And then it is also given that x plus 3 is a factor of p. A factor means when you are having p negative 3, your function would be 0. Okay, that is what it means when it is a factor. When p is divided by x minus 1, the remainder is 16. What does it mean? Remainder of 16 means when you have p 1, it must be the opposite sign. Okay, the value of your function would be 16. Okay, remember, if it is a factor, it doesn't have a remainder. That's why it is 0. But when it has a remainder, then it will be the remainder itself. Next, find the values of a, b, and c. Let's equate them out. First thing first, this is going to be your polynomial. It says there it is given that p prime 0 is equal to 12. So let's work on the first derivative. P prime 0, okay, means that you are going to differentiate the polynomial once. So ax cubed would be 3ax squared. Okay, and then our x is 0. I'm just going to substitute it right away. X is 0 square. Okay, and then I'll be having 11 times 2, that is 22. X is 0 to the power of 1, and then bx would just be b, and this is equal to 12. From there, this part is going to be 0, this is 0. You will figure that b is equal to 12. Next, when you have p negative 3, means that in the place of x you will be substituting negative 3, then you will be having a negative 3 cubed plus 11 negative 3 square plus b negative 3 plus c, which is going to give you 0. Okay, which is going to give you 0. Hold on. We found b, you can substitute it there, which is 12. Okay, so from this equation, your unknowns are just a and c. Simplifying this, you should be having, or you should be able to write 0 is equal to negative 27a plus 99 minus 36 plus c. Therefore, you can rewrite maybe c is equal to positive 27a minus 63. Okay, so that's what you get from p negative 3 equals to 0. You've done this. What about p1 equals to 16? Again, you are just substituting x with 1. p1 would be a1 cubed. Okay, I'll just leave it as 1 plus with 11, 1. That's right, so you don't get confused. Plus b is 12 times 1 plus c, and this is equal to 16. Right? Simplifying this, then you'll have 16 is equal to a plus 11 plus 12 plus c. Rewriting this, you can have negative a minus 7 is equal to c. Right? Now you have both equations in terms of c. First equation, second equation in terms of c. Means that you can equate them together to get rid of the c. You're going to have your a then. Okay, So 27a minus 63 is equal to negative a minus 7. So 28a is equal to 56. Your a would be 2. When your a is 2, you can just substitute in any of the equation, the first one or the second one. You will figure that your c, negative 2 minus 7, that is negative 9. Right? So here you have got your a, you've got your c, which is negative 9, you've got your b, which is 12. How do you get marks on this question? First mark is when you attempted on the differentiation. Right? That's M1. The next mark is when you found that b is equal to 12. Right? That's A1. Next mark is when you attempt at p negative 3 equals to 0 or p1 equals to 16. So we did it here. That's your next M mark. Next mark is when you get both equations right. Okay? That's M1 again. Next mark is when you attempt to solve your equations together. For me, I'm having it here when I equate them together. And the last mark is when I have a equals to 2 and c equals to negative 9. That is my last mark. So altogether, 6 marks. Yeah. Next, question number 7. When e to the power of 5y is plotted again, x cubed, a straight line passing through the points negative 2.56 and 4.38, and 6.54, 9.84 is obtained. Find y in terms of x. So this is a straight line. Straight line means you're having an equation that is in the form of y equals to m is the gradient, x is whatever in your x-axis, plus c. In our situation, our y-axis is e to the power of 5y. Okay, that's on our y-axis. Our x-axis is x cubed. Okay, and all these coordinates, you have to remember this is not x, y, x, y. This is now x cubed e5y. X cubed e5y. So when you substitute, you have to remember because that is in your position of x and y over here. If you can recall, it is in the form of y equals to mx plus c, where m is your gradient and c is your y-intercept. How do you find your gradient? Your gradient is basically y2 minus y1 over x2 minus x1. Okay, a gradient. Remember, gradient is the difference in the y. I'll write it here. All right, the difference in the y to be divided with the difference in x. So how do you do this? You are given two coordinates over there. Gradient is basically 9.84 minus 4.38 to be divided with 6.54, your x, your second x, to be subtracted with negative 2.56. Okay, you should figure that your gradient is 0.6. When you have your gradient, you're basically halfway on your equation. Your equation is e to the power of 5y equals to m, which is 0.6, and your x is x cubed, plus c. Your next task is to find out the c. And how do you do that? You will be able to do so when you substitute any of the coordinates you have there. So let's say I want to use my second coordinate over here. My e to the power of 5y would be 9.84, okay, which is equal to 0.6, and x cubed there is going to be 6.54 plus c. Then you will find that your c is 5.92. You've got your equation already, which is e to the power of 5y is equal to 0.6 x cubed plus 5.92. But the question is asking you not to write e to the power of 5y. Instead, it's just a single y. So you have to think about how do you bring down this 5y. Okay, because you only need the y. Remember, the reverse of e is ln, which is logarithm with a base of e. So you're going to give ln on both sides. You'll be having ln e to the power of 5y. That is equal to ln of everything over here, which is 0.6 x cubed plus 5.92. Okay, now ln e to the power of 5y, it is just 5y. That is equals to ln of everything again, that is 0.6 x cubed plus 5.92. Then your y would be 1 over 5 ln of everything there, 0.6 x cubed plus 5.92. And you're done. Okay, you're done when you are able to write y equals to something x. Okay, and how do you get marks for this question? You'll get the first mark when you write your equations with e to the power of 5y and x cubed. Right? Means that when you have this is basically your independent mark 1. The next mark is when you are able to substitute any of the coordinates into your equation, right, with any gradient that you have. That is a method mark 1. The next mark is when you got m is equals to 0.6. This is m1. And when you get c equals to 5.92, this is m1. And final mark is when you are able to write y, okay, without any other coefficient, which is just a single y in terms of x. That is a 1. Okay, altogether 5 marks. Next question is asking you to find the values of x for which y can exist. Y can exist. You see, your equation is y equals 1 over 5 ln of this. Now, in order for y to exist, whatever inside the ln, it must be positive. Can't even be 0. Look at this. When you have ln 0, you basically have to think about e to the power of what would give you a 0. E to the power of 0, is it 0? No, it's 1. What about e to the power of negative 1? It's 1 over e, right? So you don't have any value that would give you a 0. So one thing you have to remember with logarithm is whatever in the bracket, it must always be more than 0. So you just need to equate that 0.6x cubed plus 5.92 must be greater than 0. Okay, therefore your x cubed must be greater than negative 5.92 over 0.6. That means your x must be greater than negative 2.14. How do you get marks for this? You get the first mark when you use whatever inside your ln. This is your m1. Second mark is when you are able to have x more than negative 2.14. This is a method mark in finding that, and then correct answer is your last mark, A1. Altogether, 3 marks. Next question, question 8. Given that f double prime x is equal to 3x plus 5 to the power of negative 2 over 3, and f prime 1 is equals to 6 and f1 is equals to 20, find an expression of fx. First of all, what is f double prime? I think I did mention about prime earlier. Prime is basically first derivative. So you're expecting double prime to be second derivative. And how do we go about these derivatives? Remember, the inverse of derivative is just an integration. Okay? Means that if you already have f double prime x, that is 3x plus 5 to the power of negative 2 over 3, you can reverse it by integrating this to have f prime x. So integrating 3x plus 5 to the power of negative 2 over 3 with respect to x, then you would be having what happens when you integrate again? When you integrate, your power will increase, and then you are going to divide with the power, and what happens with the numbers inside the bracket? You are going to divide with the derivative of those whatever inside the bracket. Okay, let's do it again. Remember, the power will increase by 1, so you have here 3x plus 5. Now negative 2 per 3 plus 1 plus 3 per 3. That would give you 1 over 3. And then you are going to divide with the power, which is 1 per 3. You are also going to divide with whatever the derivative from your bracket. So 3x plus 5, you differentiate that, you'll get 3. Okay, 1 per 3 times 3, that's just as simple as 1. And don't forget your c. Okay, you got here your first derivative. And how do you find the value of c? You will make use of the value given to you, which is f prime 1 is equal to 6. F prime 1 is 3 times 1, which is 3 plus 5 to the power of 1 per 3 plus c. And this is equal to 6. 5 plus 3 is 8. 8 to the power of 1 per 3, that's 2. Okay? 2 plus c is equal to 6. Therefore, my c is equal to 4. Your equation of first derivative, hence, it's going to be 3x plus 5, power of 1 per 3, plus 4. Okay, now how do you get to fx? That is what the question is asking you. All right. Again, you are going to do integration. In order for you to find fx, you just need to integrate 3x plus 5 to the power of 1 per 3 plus 4 with respect to x. What happens when you integrate this? Remember, the power will be added by 1, and then you're going to divide with the power. You're also going to divide with the derivative of whatever in the bracket. So you are expecting to have 3x plus 5, 1 per 3 plus 3 per 3 is 4 per 3. Then you are going to divide with 4 per 3. You're also going to divide with 3. Okay? And what happens when you integrate 4? Don't forget, you still have 4 over here. You integrate 4, you will be having 4x. X to the power of 1 divided by 1 is just 4x. Don't forget your c. Right? Simplifying this, you will be having 3 removed, and you will be having 4 over there. What can you substitute in order for you to find the c? You can substitute that f1 is equals to 20. Therefore, f1 would be 3 times 1 plus 5. That is just 3 plus 5 to the power of 4 over 3 divided by 4 plus 4 times 1, that is 4, plus c is equal to 20. Right? Finding this value, then you should be having 4 plus 4 plus c is equals to 20. Therefore, your c is equal to 12. So you have got the expression for fx with your c equals to 12, which is 3x plus 5 to the power of 4 over 3 over 4 plus 4x plus 12. Okay? And how do you get marks for this? The first mark is when you are able to reach up until the point when you have this, right? No matter what is your c, no matter what is your k. In our situation here, k is just 1. Whatever the value of k is, you are going to get your first mark, M1. The second mark is when you figure that, oh yeah, your k is 1, because it's 1 per 3 times 3. You're basically having a denominator of 1. That is going to be your A1. Next mark is when you are using the idea that f prime 1 is equal to 6. right? When you equate them together, you will get your next m1. And then when you are able to write that f prime x is equal to all those things plus 4, okay, that is the accuracy mark. Next mark is when you are integrating it again, and whatever the constant is, but as long as you have this part over here, you are going to get the next m1. Okay, the next mark is when you realize that, oh, you still have your x. Okay, with whatever value of constant in the front, whatever the constant here, and even if you haven't found c yet, you will get the next m1. The next mark is when you are able to equate this equals to 20, when you are using the idea that f1 is equal to 20. That's another m1. And finally, when you are able to write, okay, fx is equal to all these things accurately with your c is equal to 12, then you will be having a1. Altogether, you have there 1, 2, 3, 4, 5, 6, 7, 8. Yep, 8 marks. Okay. Next, question 9. The equation of a curve is y equals to 3 to the power of negative 3x plus 2 over x plus 1, where x is less than negative 1. Question asks you to show that dy over dx is e to the power of negative 3x plus 2 over x plus 1 square times ax plus b, where a and b are integers to be found. The equation given to you is in terms of y, and you want to find the derivative. If you see, you want to differentiate with respect to x, and your x in your equation, you have it on the numerator, you also have it on the denominator. Means that you have to use the quotient rule. What is a quotient rule? Quotient rule is when you are trying to differentiate something that is in the form of u over v. Or exactly the same situation that we have here, in which our u is e to the power of negative 3x plus 2, and our v is x plus 1. Okay? And what happened when you differentiate u over v with respect to x? Then your dy over dx would be v to be multiplied with the derivative of u to be subtracted with u multiplied with the derivative of v over v squared. Okay, so let's think about what is your du with respect to x. Okay, du dx, e to the power of negative 3x plus 2. Now, I'll put it on a side note over here. When you have e to the power of x and you want to differentiate this with respect to x, okay, differentiating e power of x, you are going to simply get e power of x. That is because your x is to the power of 1 and coefficient is 1. Let me change the situation. You have e to the power of 2x and you want to differentiate this with respect to x. And what will happen? You will be having e to the power of 2x to be multiplied with whatever the derivative of your power, which is 2. Okay? Or I can rewrite this to be 2e to x. I'll change it a bit. You have here e to the power of 2x squared, and you want to find the derivative with respect to x. What will happen? You will still have e to the power of 2x squared. You can see that I'm just rewriting this, and I am going to multiply with the derivative of the index of e, which is times 4x, or it will be 4x e to x squared. Okay, we good? So therefore, if you have e to the power of negative 3x plus 2, it is simply going to be e to the power of negative 3x plus 2. Remember, I'm just rewriting my e, and then I'm going to multiply with the derivative of the power, which is times negative 3, right? And I can rewrite this to be negative 3 e negative 3x plus 2. What about v? Derivative of v with respect to x is just 1, right? Differentiate x, you get 1. Differentiate 1, you get 0. Therefore, if I want to find dy over dx, then it's simply v times du. My v is x plus 1. My du dx is negative 3 e to the power of negative 3x plus 2. And then I have to subtract with u, which is e to the power of negative 3x plus 2 times 1. Okay, I'll just keep that over v squared, which is x plus 1 squared. We're almost there, I think. I can see x plus 1 squared over there, but I don't quite see this and ax plus b. So we have to do something. You have to factorize, right? You have to factorize the common. You can see here we have common term, which is in the form of e to the power of negative 3x plus 2. You also have it here, okay? Now think about how do you factor it out. It is going to be e to the power of negative 3x plus 2, isn't it? Now, when you factor it out from x plus 1 and negative 3, it is just going to be x plus 1 times negative 3, right? I'll put it in the bigger bracket. Okay, that's from our first group over here. What about from the second group? It's just minus 1. You see, the first group is this one. So I have x plus 1, and then I have negative 3, which is coming from here and here, right? And then minus 1 is basically coming from minus e to the power of negative 3x plus 2. My denominator remains the same, which is x plus 1 square. Okay, I feel that I've got my numerator, right? Means that I just need to simplify to get into the integers of a and b, which is, this is going to be e to the power of negative 3x plus 2 over x plus 1 square, right? And then I just need to simplify that. I should have negative 3x minus 3 minus 1, which is, this is going to be minus 4. All right, I'm just going to erase it, okay, which is minus 4. And I'm done. My a is negative 3, my b is negative 4. And how do I get marks for this? This is 5 marks altogether. My first mark is when I am able to find the derivative for du, right? This one here. This is the first b1. Second mark is when I am doing an attempt, correct attempt to the differentiation of a quotient using the rule. This is m1. And then the third one is when I got all terms correct. All right, all terms correct, then I'll get a1. The next one is when I attempt to obtain to the given form. So if I stop there, I won't be getting the next 2 marks. When I am trying to approach to the form given to me, I'll be getting a method mark. And if the form is correct, my number a is negative 3 and b is negative 4, then this is a1. Okay, next. Hence, show that there is only one stationary point on the curve and find its exact coordinates. Stationary point means that your dy over dx is equal to 0. So you just need to equate this to your function earlier, which is e to the power of negative 3x plus 2 over x plus 1 square times negative 3x minus 4 is equal to 0. Your aim is to find out the coordinate of x. When this is equal to 0, you should get an idea that when you have two things that has been multiplied to be 0, for example, a times b is equal to 0. This is when you do the quadratic equation, right? For example, when you do x minus 1 times x minus 3 is equal to 0, then you would say that, oh, x minus 1 is equal to 0 or x minus 3 is equal to 0, because that is basically what happens when you multiply two number becoming 0. It's either the first number is 0 or the second number is equal to 0 or both numbers are 0. Okay, that's what happens. But in this situation, you are going to expect that either this is 0 or this is 0. But you should be able to see that it is impossible. Again, it is impossible for e to the power of negative 3x plus 2 would equal to 0. Okay, means that the first part here should never be equal to 0. That's the first point. Since it is not the first group, it must be the second group that is equal to 0. Negative 3x minus 4 is equal to 0. Therefore, your x would be negative 4 over 3. When your x is equal to negative 4 over 3, then your y, which is e to the power of negative 3x plus 2 over x plus 1, then it should be e to the power of negative 3 times negative 4 over 3 plus 2 over negative 4 over 3 plus 1. Should be getting a value of negative 3 e or 6. Okay? And how do you get marks on this question? You'll get the first mark when you realize that it is not coming from the first group. Right? Basically, your answer is just coming from here. When you write that this is not equal to 0, or when you say that this is rejected, or those kind of things, right? You'll get the first mark, just B1. The second mark is when you get x equals to negative 4 over 3. That is another B1. The last mark when you substitute x into your equation and getting y equals to negative 3e power of 6. That is your B1. Okay. Next question, number 10. The third and eighth terms of a geometric progression are 6 and 1, 4, 5, 8 respectively. Find the common ratio and first term of this progression. So this is a geometric progression which is not moving by common difference. Instead, it's a ratio. Okay, maybe we can write it down. So U3 is 6, and then U8 is 1, 4, 5, 8. For geometric progressions, UN is simply A, the first term, times with a common ratio to the power of n minus 1, means that if it is U3, it is going to be A R square, that is equal to 6. If it is U8, means that it is A R 7, that is equal to 1, 4, 5, 8. You should think of a way on how you can get rid of one of this. My way would be, I'd like to divide them. So AR7 over AR square. In that sense, my A would be eliminated. Is equal to 1458 over 6, which is 243. My A would be gone. My R would be 5. So R to the power of 5 is equal to 243. And R would be equal to 3. I've got my R. How do I find my A? I can just substitute into U3, which is A times R square. 3 square is equal to 6. 3 square is 9, so A is equal to 6 over 9, which is 2 over 3. I've got everything needed from the question. How do I get mark from this? I'll get the first mark when I figure AR square and AR7. When I'm able to write them in this kind of form, this is my first mark, B1. Second mark is when I'm able to equate R5 equals to 243, B1. Third mark is when I found R is 3. Last mark is when I found A is 2 over 3. Okay, all 4 marks. Question B. The first three terms of a second geometric progression are cos theta, 2 cos squared theta, 4 cos cubed theta, where theta is from negative 90 to positive 90 degrees. Find the values of theta for which this geometric progression has a sum to infinity. They don't ask you to find the sum to infinity, but they want you to find the value of theta for which the geometric progression has sum to infinity. When it has sum to infinity, means that your modulus R would be less than 1. Okay, that's one thing you need to remember. It's given in the formula, actually. Let me show it to you. It's given in the formula here. For sum to infinity of geometric series, in order for a geometric series to have a sum to infinity, your modulus R must be less than 1. Okay, so using that idea means that your R must be between negative 1 and positive 1. You know that your A, your first term, is cos theta, and your R would be the second term divided with the first term, which is 2 cos squared theta over cos theta. That would give you 2 cos theta. Alright, this is your R. Now you know that R is between negative 1 and 1. So 2 cos theta would be between negative 1 and 1. What about cos theta? Then cos theta, you're going to divide both sides with 2. Should be between negative half to half. You should realize that theta must be between negative 90 degrees up until negative 60 degrees. Okay, this is just the inverse of cos. But to fit in within the range given to you, because theta is within negative 90 to positive 90, you should realize that there is another range that is possible, which is from positive 60 to positive 90 degrees. Right? There are two ranges in this situation. How do you get marked for this question? Your first mark is when you figure that R, the ratio for this geometric progression, is 2 cos theta. This is your B1. Second is when you are able to reach up until negative half is less than cos theta, which is less than half. This is a B1. And then when you are getting those two ranges, this is B1, this is another B1. Right? Altogether 4 marks. Question 11. The diagram shows part of the curve y equals to 4 plus 2 sine 3x and the straight line AB. The points A and B lie on the curve. The x-coordinate of A is pi over 18 and the x-coordinate of B is pi over 3. Find the area of the shaded region, giving your answer in exact form. So this area is bounded by the area under the graph of y equals to 4 plus 2 sine 3x and the straight line AB. You can see that if you find out the area under that curve bounded between A and B, you will be getting an area of this much. Means that to get the shaded region given to you, you need to subtract with the area of this trapezium. Right? This is just a trapezium, isn't it? Because they have parallel sides. Okay, so your task is to think about what is this height and what is that height, because that's going to give you the area of trapezium. How do you do that? Well, you know that at this point A, your x is pi over 18. And at this point B, your x is pi over 3. You can substitute into the equation y equals to 4 plus 2 sine 3x to find out what is the y and what is the y over here. Okay, so let's work on it. When your x is pi over 18, then your y would be 4 plus 2 sine 3 times pi over 18, which means your y is equal to 5. When your x is pi over 3, your y is 4 plus 2 sine 3 times pi over 3, which means your y is equal to 4, right? So there you get that this is 5 units and this here is 4 units. The area in the graph would be an integration of the function 4 plus 2 sine 3x bounded from pi over 18 to pi over 3 with respect to x. Okay, now what happened when you integrate this function? Integrating 4, you're just getting 4x. Integrating 2 sine 3x. 2 would remain there. 2 is just a constant. Integrating sine would give you negative cos. Alright? Multiplied with negative cos means that the sign for 2, I'll just change the sign for 2. It will be minus 2 cos 3x, right? 3x would still remain there, but I'll have to divide this with the derivative of 3x, which is 3. And then I need to apply the limit, which is from pi over 18 to pi over 3. Next one is just substitution. 4 times pi over 3 minus with 2 over 3 plus 3 times pi over 3, and then to be subtracted with 4 times pi over 18. Let's see. Okay, I'll change the sign to plus because I basically need to minus minus. All right, plus 2 over 3 cos 3 times pi over 18. Right? And this would give me, in terms of pi, which is 10 pi over 9. Without pi, I have here 2 over 3 plus 3 over 3. Okay, but don't stop there because you haven't subtract with the trapezium. I'll start here again. Okay, so the area of the shaded would be whatever answer I have earlier, which is 10 pi over 9 plus 2 over 3 plus 3 over 3 would be subtracted with the area of trapezium. You remember the formula for area of trapezium, which is half times the summation of the parallel sides, which is 5 and 4, and then times with the width, which is, in our situation, it's going to be pi over 3 minus pi over 18. Yeah. Calculating for that, you should be having 2 over 3 plus 3 over 3 minus 5 pi over 36. How do you get marks for this question? Let's start from the top. You'll get the first mark when you integrate correctly, when you have 4x and whatever constant with cos 3x. That's your M1. Next mark is when you have this accurately. That's your A1. Okay, next one is when you apply correct limits. Okay, correct limits when you subtract them. So this is M1. Next one, for the final answer. One correct term would be 1 mark. 3 correct terms, 2 marks. So all here would be A2, 2 marks. Next mark is when you are able to find out the limits of the trapezium, okay, which is 5 and 4. This is B1 and another B1. And then when you're figuring out that the area of trapezium is 5 pi over 4, which for me is located here, B1. And lastly, when you are able to get that the shaded area is this, okay, A1. Remember that the question is asking you to give it in exact form. So do not convert it into decimal, even though your number is not that nice. Next, question number 12. Solve the equation 2. Cosecant squared theta minus 5 is equal to 5 cotangent theta for theta between negative 180 to positive 180. First of all, if you're going to solve this, you need to remember you have to write this into constant trigonometric ratio. For example, in this part, you still have cosecant and you have cotangent. All right. One way is to write everything into cotangent because you do have an identity that relates cosecant and cotangent, which is cosecant squared is cotangent squared plus 1. Okay, and then you have minus 5 is equals to 5 cotangent theta. You can expand this. You will be having 2 cotangent squared theta plus 2 minus 5 cotangent theta equals 0. You will end up into a quadratic form, which is 2 cotangent squared theta minus 5 cotangent theta minus 3 is equal to 0. You can see that in this form, your A is 2, your B is negative 5, and your C is negative 3. And you can factor this out into 2 cotangent theta plus 1 and cotangent theta minus 3 is equal to 0. Right? Remember what happens when you have two things multiplied together that is equal to 0, then one of them must be 0. So you're saying that either 2 cotangent theta plus 1 is equal to 0, then cotangent theta is negative half, or cotangent theta is equal to 3, right? Cotangent is just 1 over tangent. So 1 over tangent theta is negative half, or 1 over tangent theta is equal to 3. Okay? Thinking about tangent theta, then you will have this switch up is equal to negative 2, and tangent theta is equal to 1 over 3. Once you have found your tangent theta is negative 2 and tangent theta is 1 over 3, how do you get your theta? One thing you need to remember when we talk about trigonometric ratio, on our quadrants, the first quadrant, all trigonometric ratio will be positive. On the second quadrant, it's only sine that will be positive. Third quadrant is tangent, and fourth quadrant is cosecant. How I remember this is by add sugar to coffee. Okay, you can remember the same way or you can have your own way. It's fine. Now, looking at this, my first tangent theta is negative 2. Then I should expect that my theta is located in the second quadrant or in the fourth quadrant, because in that position my tangent theta is negative, right? Which my theta is located here and here. If you use your calculator, you will figure that theta is 63.4 in degrees. 63.4. So if my theta is located in the second and fourth quadrant, and you should see that the angle that will be covered is going to be this one, which is going to be 180 minus 63.4. Okay, so you should get 116.6. That's my first angle. What if it is located in the fourth quadrant? If you see, the range is from negative 180 degrees to positive 180 degrees. So I cannot find the angle by calculating it this way, right? Because it's going to be out of the range. What I can do is I'll go negative way, which means from 0 degrees, I'll go the opposite direction. So this is my angle. In that sense, my theta would be, second theta would be negative 63.4. Okay. Now, for the value that tangent theta is equal to 1/3, since my tangent value is positive, we are expecting that my angle would be on the first quadrant or on the third quadrant, which this is my theta and that is my theta. Remember that theta is always the one attached to your x-axis. So if you use your calculator, tangent theta is 1/3, then you should get that theta is equal to 18.4. So that's going to be my first angle over here from 0 up until this point is 18.4. The next theta is going to be, see, I cannot go again, yeah? I cannot go from 0 up until this angle because it's going to be out of the range. What I can do is, I can go from the other side, from negative theta up until this point, right? This is our line. I can write negative 180 plus 18.4. Then you should get negative 161.6. Okay, let's check again. 63.4. Now you have to indicate that this is not it. You can just put a small cross over there. Alright, 116.6, yes, it is within the range. And negative 63.4 is also within the range. The reason why we don't accept 63.4 is because when tangent theta is equals to negative 2, we are expecting our angle would be located in the second quadrant or the fourth quadrant. 63.4 is an acute angle, right? It is located in the first quadrant, so we don't accept that. But 18.4, even though it is an acute, it falls within the positive values of tangent, right? So we take 18.4. The next one is negative 161.6. How do you get marks for this question? The first mark is when you are able to substitute the identity of cosecant and cotangent. That's your B1. Next mark is when you are able to get a quadratic equation. This is M1. The next M1 is when you are solving the quadratic cotangent equation. Remember, you have to show the factorization, or if you are using a formula, then you have to show that you are substituting the value of A, B, and C into the formula. Okay? The next mark is when you have tangent theta equals to negative 2 and tangent theta equals to 1/3. So I got it here and here. That is my M1. Okay? The next mark is 3 marks, which is for your angles. First mark is when you have a correct solution. So I have a correct solution when I have 116.6. I get M1 over there. The next A1 is for another correct solution. I got A1 over here. The last mark is for further 2 correct solutions and no extras in the range. So I got that when I have 18.4 and negative 161.6. But remember, if you did not put a little cross over here, that would be read as your extra angle in the range. Right? So you have to be careful. You need to check whether that is an answer that you want to submit to your examiner or it's not. If it is not, then you have to make it clear that that's not part of your answer. Make a little cross, or you can just cross it out using a line like this. All right, so only 4 would be needed. So that is A1. Moving on. Next question. Solve the equation 3 sine 2 phi plus 1.5 equals to 2 for phi between 0 to 5, where phi is in radian. So you have here 3 sine 2 phi plus 1.5 is equal to 2. Therefore, sine of 2 phi plus 1.5 is equal to 2 over 3. Now, positive sign is located on the first and the second quadrant, isn't it? The third and fourth is only for tangent and cosecant. Means that you are expecting this angle to be located, phi is here or phi is here, right? In which it must be from 0 to 5 radians. Solving this, sine of that angle is equal to 23, means that the angle, which is 2 phi plus 1.5, is equal to, in radian, 0.7297. 0.7297 if it is located in the first quadrant. If it is located in the second quadrant, it is basically just pi minus 0.7297, which is 2.4119. Okay, but this is, remember, this is not yet the phi. This is still 2 phi plus 1.5. Okay, the reading from the sine. Hence, your first phi would be 0.7297 minus with 1.5 divided by 2, which you will be getting negative 0.38515. Okay, I'll check on the region afterwards. Okay, you probably can see now that it's not within the range, which is 0 to 5. This is negative number, right? The next phi would be when I have 2.4119 minus 1.5 and then divided by 2, I would get 0.456. And you can see that this one is falling within the range. This is not. This is it. Okay, but please do not stop there. It could go from this to that, this up until here, or it could go from one whole cycle up until this angle, which is 360. 360 is just 2 pi. Okay, 2 pi plus 5. Continuing from that, you should be getting the third one is 2.76. The next one would be 3.60. Continuing from that round, you will be having 5.90, in which the first one did not, right? Did not fall within the range. The second one does. The third one does. Fourth one, yeah. The fifth one, no. So only angles that fall within the range are these 3. And how do you get marks for this? You'll get the first mark when you equate sine of that angle equals 2 over 3, in which 2 phi plus 1.5 is equal to 0.7297. This is M1. Next mark is when you figure the repetition, right? So when you have 2.4119 at least, you'll get your A1. Now, the next mark would be when you have correct order of operations, in which when I get 0.456, this is M1, and then A1 for one correct solution. This is also my A1, and then the next A1 is further 2 correct solutions. This is A1. So altogether, it's 5 marks.
Now this video doesn't cost you anything, but perhaps for its support, you can click the subscribe button.